hello. I need to switch, right?
Yes.
Could you do this for me, and I'll start. Good afternoon, everybody. Thanks for having me. Thanks for coming, most of you for the first time. I'm really happy to see that so many people are interested in crime, or crime detection, hopefully. Yes, I came all the way from Prague. And I'm Kateřina. I actually did my PhD at the Faculty of Mathematics and Physics at Charles University. This is where I teach, and part of my job is actually teaching also forensic linguistics. And I did my PhD in the field of natural language processing or computational linguistics. And I wrote a book on sentiment analysis. That's my major field, and I'll explain how is it actually connected to forensic investigations. And my second job, the job for living, to be honest. Otherwise, I would stick with academia, but it's quite difficult to live on it. So I decided to join Deloitte, which is an audit company. And of course, audit is very often connected to fraud detection and mostly financial crime investigation. And that's how I ended up in semantic analysis. So I'm responsible for Central Europe, which means 28 languages, more or less, and for generally the unstructured data analysis, but of course it's mostly connected to forensic investigations, as I've mentioned. Now, how I actually ended up doing that or bothering the topic I'll be speaking about today. Well, at the very beginning, I started with this one university project, which we were actually working on together with the Ministry of Interior of Poland. And there was a machine learning system that was supposed to be able to predict murder, or the training data we had was a corpus of the suicidal letters. The suicidal letters collected from the closed cases, so we knew whether these people actually killed themselves or whether they were killed. And we were training a system that would say, or that would estimate the likelihood that the letter was authentic or that the letter was fake and the person was killed by someone. Well, there was the traditional naive Bayes classification, so we were feeding the system with the authentic and the fake letters, and then we were actually checking on them to discover the features in them. And that's why I was actually invited to this project, because it has to do with semantic analysis. It turned out that when people lie, they tend to use much more positive emotions than if they are being authentic. So in the authentic letters, we realized that the overall sentiment of the letter was more or less neutral. And the vocabulary was very specific, very particular. It was things like, don't forget to pick up this and this in a grocery store and go with the kids to kindergarten, and so on and so forth. The vocabulary in the fake letters was, however, quite generic. Things you know from the movies. Things like, I loved you all, but I now need to go, and you know, it sounds fake already, but finally I've got the proof. And from the computational linguistics perspective, we realized that when people were being authentic, they were using much more complex and longer sentences, whereas in the fake letters, the sentences were significantly shorter, and the I love you all overall sentiment was always positive. And I was actually wondering how we can use these features also in the authorship identification within forensic investigations. So I was searching on forensic linguistics, and since my major was computational linguistics, I was wondering how to actually connect the natural language processing and automated analysis with the means of forensic linguistics. And forensic linguistics in general is a branch of applied linguistics, where we are trying to apply the linguistic knowledge, methods, and insights to the forensic context of law, language, crime investigation, trial, and judicial procedure. Why am I saying this? Because that's what I'm actually now working on in Deloitte, and the good thing is that we also have a team of lawyers always to help us out with or during the investigations. And the part of the data analysis is actually called electronic discovery, where we basically search, or we first collect the electronic data, and we analyze them nowadays using machine learning methods and techniques to find the smoking gun, which I'll be also talking about today, or generally find an evidence, because the smoking gun is usually a particular email or particular WhatsApp message or particular SMS within the investigation. And this can be carried out offline, but very often it's the case that I travel around Central Europe with the mobile server, because the data actually can't leave the country. I've mentioned that we always cooperate with the lawyers, because of course we always need a court order to actually start with the investigation and collect the data. Within the investigation process, it works like the company calls us, we go there with the detectives in the middle of the night, exactly as you know it from the movies, I guess. We collect all the evidence, because the problem with forensic investigations in general is that when people feel any suspicion, they of course start destroying the evidence immediately. So this all has to be very quick. And so we collect the text data, any form of text data, mostly electronic, but we collect the notebooks, the phones, any form of hard copies as well. Then in the forensic lab, the guys get rid of, or they make the images of the notebooks, then they get rid of Windows installations and any kind of irrelevant data. And what I get is usually the emails or any form of textual data. And then I perform the analysis, which I'll explain in detail. But back to the forensic linguistics, because it's it's a very young discipline, and there are actually no subject matter experts really in this country. There is an Institute of Criminalistics, where there is one quite old lady sitting there doing some graphology magic, but it's mostly qualitative so far. Within the list of occupations, you would probably find it within criminalistics. But I also use the means of text analytics and NLP. But very often we also use forensic phonetics, or we also call it phonoscopic acoustics. These are the cases when someone calls that there is a bomb somewhere and we need to analyze the voice pitch also, so the audio data. I like to say, and I emphasize it to my students very often, that language material, the traces we leave all around the place, works as a fingerprint. No one has the same language as someone else in the entire universe. Like, we all use different syntax, we all use different vocabulary. This is based on the fact that, I don't know, your grandmother was Polish, or she was born in Brno. There's a specific dialect somewhere in the family. And that's called idiolect, that we all use a very specific language. And my job is, by the way, to do the authorship identification based on the referential data and find these traces people leave. This helps us also to put together the psychological profile of the suspect, because this is also expressed in the language, and it has to do with sentiment analysis, that some people can be more aggressive, and it's crucial for the interrogations because we want to know how to handle the suspect. And it also has to do with forensic medicine, because it's very often the case that the person has some specific type of, I don't know, like me, I'm currently losing my voice, so it can be a vocal cords condition, or the person can be left-handed. These are all things we still can predict from the data. And of course, you need to know the jurisdiction of the given country. So generally, we can say that there is no unified methodology within forensic linguistics. There have been only developmental hikes or single case studies, and mostly people have been using qualitative approach, meaning, I don't know, when someone gets raped, people are going through their diaries manually, hoping to find some evidence or some clue. So I did my research, and I've been through the most famous case studies, let's say, and I've decided to use all these hints or all these features, as we call them within machine learning, in the automated analysis I usually use. So. For instance, the very first case of the forensic linguistics is from the 60s. It's Rillington Place number 10 case, where basically the suspect was forced to give the explanation or to admit that he committed the crime because he was repeating exactly what the criminalist was saying. So they were comparing the syntax of his sentences with his previous language material, and they realized that actually he made a confession under the pressure. So syntax is one good clue we can actually measure. You've probably heard about Unabomber University and airline bomber from the US. That's this guy, Theodor Kaczynski. He's still around, by the way. And he was fighting the technological development of humankind and putting bombs to different places in the US. And but he was also writing manifestos and sending them to the newspapers. And the forensic linguists actually realized that the guy must be highly educated because of his vocabulary, and that he is probably from somewhere around Chicago because of his dialect. And these were the two important clues that led to his brother actually realized that it must have been him because of the vocabulary and the high intellect. So vocabulary and the dialect are definitely other features we use. And then recently, and these are the cases we are usually working on to some extent as well, that people, for instance, kill someone, like the guy who killed Johnny Nichols, or the guy who killed his wife, and he was sending messages from her phone pretending it was her. But based on the syntax and the style of the messages, they realized that she was not the author of these messages, and she must have been killed by the time the messages were sent. So, based on these cases and some other literature, mostly from Anglo-Saxon countries, I've put together the cases that can be also useful for us, not only within Deloitte, but also that are interesting in context of the academic research. And these are different areas where we can actually use the author identification. Very often it's the thread letters, but also mobile phone texts and emails. And you would be surprised, but I also work with these cases in Deloitte. Very often it's blackmailing or even sexual harassment, and we need to find the author. But it can be informing letters or informing calls. It can be blackmailing letters, including racketeering. For Deloitte, for instance, it's very often law documents intervention when you see that the entire document is written in one style, and then there is one paragraph that is written in completely different style. And based on these tiny little clues, like the style or the syntax, we are able to say, okay, there is something suspicious. And yeah, the mentioned sexual harassment, which has to do with psychological profiling of the suspect, and the hapaxes as well. Hapaxes are actually the words that are used only once in the entire data set. I can get back to that, but by the way, the case of a sexual harassment was kind of interesting because I said that you always need to know the jurisdiction of the specific country, and this was the Asian company, and there are totally different policies when it comes to sexual harassment in Asia. So they ask us to basically kick off the guy at the very moment, and our lawyers had to explain that it would be against the employee's law, so we can't do it. But what I got was a set of emails, and I was supposed to find the content of sexual harassment. And since it was not in my NLP ontologies, I had to download basically the categories from the porn websites to find the relevant vocabulary. And I made it. Learn so much of a new stuff, on the way. So sometimes the other areas can be disputes of meaning and use. Like we, for instance, did some experiments with the rights of the suspect, meaning that people very often don't understand their rights. When you read this general sentence for them that these are your rights, you don't have to say anything until the lawyer is around or something, they don't really understand what you are talking about. Or once I had to solve the semantic issue with the prostitutes because in certain words the prostitute can feel offended if you call them these expressions, so we had to come with something neutral. Or in the cases of defamation of character, when you say about someone that he's a pig and he wants to suit you, there must be a linguist who would say, okay, pig is really a swear word nowadays, or it's not. Probably it's not. Then it would be trademark properties, intellectual properties. Only recently I've been on a case where people were stealing know-how from the company, and we had to prove that in these emails they were actually discussing the know-how and that it is a crime of stealing intellectual property. Or it can be plagiarism within or in the academic context, voice identification, as I've mentioned already. Basically there we always compare the voice of the defendant with the one that is taped on the record. But I was also doing some experiments with silence. It is the diploma thesis that I'm supervising, and we are actually looking for semantics of silence, like what people think about and what's the following context or content when they stay silent for a while. Does it mean that they're going to be lying? Are they just nervous? And so on and so forth. And the first component of our automated solution is actually the first language identification. It has some other specific reasons I'll be talking about today, but one of them is also that we were asked to trace the history of asylum seekers, because they very often say that they come from one country, but then it turns out that they don't even speak the language. And we can identify the first language based on the second language you use. So if you would be born, I don't know, German, you would probably use German syntax in your English sentences. So you would always be putting the word at the end of the sentence. And these are the things people do totally involuntarily. So it's also a good clue for the first language identification. And then there is this huge topic of social networks. We use them for the background checks, because not only we inquire the emails, but we also need to know who talks to whom, who is friends with whom, and what these people were talking about. They very often say that they don't know each other, but then we realize that they have mutual friends on Facebook, or they were commenting something on LinkedIn, or they were sending messages via Twitter. And actually, my today's demo will be about how we actually perform the background checks, how to do that. On the social networks, it's very often the case of illegal content, like sexual harassment or hate speech. Actually, you've probably noticed that hate speech nowadays is considered a crime, and you can be sent to jail for doing that. And we actually try to detect the hate speech automatically, also using sentiment analysis, namely the negative expressions. It can be potential terrorism on the social networks. I'm being filmed, so I can't really go into the details, but what we usually do is that we find some potentially threatening content on the social network, and then I just say that in this part of the data it may be connected to some potential terrorism, and then I hand it over and I can't even know what's happening with the data afterwards. But it's also very often connected to image analysis. It's very often the case that there is a picture of someone who killed someone else, is considered a hero, there are very positive comments, and it's usually a very good clue that it may be a potential terrorist or person with friends who know friends, and so on and so forth. And cyberbullying, I'll get to that. Now, you can go through this threatening message yourself and think about what types of features we can actually learn from such type of message. Well, first of all, it's very old-fashioned, so whoever is the author, it must have been an old person, I would say. But not only that, there are many other identification attributes. So based on your language, we can identify your gender, very often in morphologically rich languages, Slavic languages, including Czech. Já jsem to udělala, so it's obvious that it's female. It can be age. We assign the age based on vocabulary very often because youngsters definitely have different vocabulary than elderly people. So neologisms, as we call them, are a good predictor for younger people. Social and local origin, again, very often based on vocabulary and dialect. Level of education, you would probably intuitively say that the more sophisticated vocabulary, the higher education. The level of aggression or adaptability, that's important for the interrogations because we want to know how to handle the suspect. Relationship to authorities, and relevancy or irrelevancy of particular people or events or sweaters or whatever is important for that person, because we can use it within the interrogations for, I'm not saying blackmailing, but using it when the psychologists interrogate the suspects, and the physical and mental handicaps, as I've already mentioned. So, what are the methods we usually use for the authorship identification, which is not graphology? We usually compare the sample we get with some referential data, with some data we know that the suspect has written. And then I've mentioned that language is like a fingerprint, so I've already mentioned some of the features, but we all have different count of functional and content words. There are no it never happens that there would be two people with the same distribution of prepositions or conjunctions. Or we even differ with the sentence length average, or even word length on average, or even average of syllables per word can differ. In the languages with articles, we again differ in the article frequency. And also type of article. Then we have the different type token ratio, and a very good hint within forensic investigations is usually a punctuation. If someone didn't learn grammar or can't use the full stops or commas or whatever, they usually do it consistently wrong. So that's a good clue how to actually identify that the text was written by the same person just because of the comma distribution, for instance. But it can be idiolect, frequent words, the mentioned hapaxis, and the overall grammar. There are different statistical approaches, depend on how many variants we take into account. So it can be factor analysis, Bayesian statistics, Poisson distribution, multivariate analysis, and the discriminant function analysis of the function words, of course, together with the vocabulary. And dimension sentiment analysis, which is basically a character and frequency of evaluative expressions, mostly the negative ones, is or has a crucial influence on the hate speech and the author detection of the hate speech. On the other hand, I'm not saying that we only use the means of forensic linguistics or NLP to find the evidence or get the suspect. So, of course, we very often combine it with some objective aspects like IP address. And sentiment analysis is being used when identifying the threat letters, terrorism, hate speech. I'm now also supervising one thesis on trolling detection, which is kind of interesting because it's just normal sentences written in strange context. So I'm also wondering what will be the outcomes. And they mentioned cyberbullying. There is a huge research on cyberbullying on the internet, or namely Facebook. They very often use again naive Bayes classification, or SVMs, or you can also use logistic regression for these things. But anyway, there is a huge amount of training data, since nowadays you have these YouTubers, like small kids that that got lots and lots of negative comments, and these comments are being manually annotated, and this is used as a training data for cyberbullying detection. And then we combine the means of sentiment analysis or negative words in combination with different types of vocabulary from different areas. So it's very often race or culture or sexuality, intelligence, or even some physical attributes. And then it's used, for instance, in Facebook. Only recently I was being interviewed by Facebook, by the Community Integrity Division, and this is how you've probably seen it already, but this is how they collect the training data. So anytime you mark something as sexual harassment or suicidal tendencies or hate speech, they retrain the model, and we also contribute with semantic analysis or cyberbullying detection to automatize this. Now, the second part probably will be more practical, and that's how we actually use, or how we look for a smoking gun in the huge amounts of data. The smoking gun as the mentioned evidence. I'm not sure if you're familiar with the different phases of forensic investigation, but I've mentioned that first of all we need to collect the data, digitalize them, perform the first analysis. Meanwhile, we are performing the background checks on the social networks. If we get some findings, we are trying to remediate the case. Otherwise, the review, the manual review of the documents needs to be done, and then we conduct the interviews. And why I was actually originally hired to Deloitte was for this, because they were using the manually created search terms. As you can see here, that they were just putting it together off the top of their heads. So, first of all, the problem is that there is a certain amount of available data, but we never collect them all. Then, after the data filtering and the search terms filtering, they were only able to find the limited amount of data, and this approach is definitely not data-driven. So, either or the review was then done only the part of the data set that reacted positively to these regular expressions, which were kind of not really functional. Why? Because even if you think it's relevant, it still doesn't have to be relevant semantically. There are languages, and especially, again, Slavic languages, the so-called morphologically rich languages, that are very ambiguous. Up to 70% of Czech words and nouns can have different meanings. And even here, English is analytical language, so it can be kind of so-so, but you have phrasal verbs that can have, like, the word cover can have up to 45 meanings. And you are only looking for some of them, the most relevant of them. And that's why you actually need to perform semantic analysis, right? Not to get all these false positives, but to get only the relevant things. So the issues they had typically seen within the manual search term identification were that they were only created based on the knowledge of the case and maybe some previous experience, but it still means that it doesn't have to be mentioned in the new data set at all. Most of the regular expressions were too broad, so basically ineffective. Or the terms that yield good results were actually narrow, or the terms that look good on paper, they wouldn't have hits at all, and there were always very little effort invested into improving the terms with the good results, so the data they got back were not really useful. This is from the real-life data, and this is what actually happens if you only use, for instance, the name of the main product or the company product within the investigation. So out of, 10 million of documents, you get 12% back, which is still a huge amount of data. And if it would be a name of a business partner, that would be even worse. So 1/3 of the data you would get back, and you would still have to go through it manually. So I came up with a sort of new cookbook for the data analysis. First of all, I've been working with vectorization, which means multidimensional space. So I needed to preprocess the data, including lemmatization and some other stuff, to actually shrink the universe of the data and reduce the number of dimensions. Then I performed something which is called early case assessment using clustering or some general topic modeling to actually see whether the data is actually even relevant for the case, to get to know whether people are only discussing family issues or whether there is actually something potentially interesting for the lawyers or for the investigators. And then after this first early case assessment, I used the cluster descriptors. You can see here, or you cannot, but the point is that each part of the cluster has cluster descriptors that can be actually enhanced using linguistic ontologies. And then I performed the topic modeling only on the relevant part of the data to get the smoking gun. This is the pre-processing. First of all, we need to perform the language identification, of course. I said that we've been working with 28 languages, so you first, before you even start with any kind of semantic analysis, you need to go through all these phases from spell checking, because especially the data from the social networks are very ugly, let's say. Segmentation, tokenization, lemmatization, and so on and so forth. You've probably, or some of you at least, seen the talk by Genia, which we closely cooperate with the last time. So for some of the languages, we use Genia tool. And then once this is done, we can start with semantic analysis as such. And concerning the expansion of the cluster descriptors, as I've mentioned, the problem is that even when the lawyers were searching for these search terms manually defined, they usually never came up with the relevant synonyms, for instance. So if you use some kind of ontology, it can be both general, like WordNet, or it can be custom, like the ontology for the specific field you are investigating. You still want to get relevant synonyms, for instance, as you can see here, or the hypernyms, the higher category of these words, or where these words belong to, or even derivationally related forms, which is kind of tricky for non-linguists, especially in the complex languages. Or some sister terms from the same family, which have no common stem or no similarities, linguistic similarities. That's one thing. The other thing is the coding speech. Like till the end? 10 minutes? Sorry, okay, I'll be quick. Very often is the case within forensic investigations, and this is the project we've done at MATFIS, that for instance, the human translators or interpreters were on the side of the investigated suspects. So now Czech police, they are rather using the machine translation from Vietnamese than putting up humans in place, because the humans were actually spoiling the investigation. And that's very often the case with the written data, that people think that if they start using the mother tongue, we will never get to know that there is something suspicious going on. So that's why we always use the language models to see, okay, half of the email is written in English, the other one is in Arabic, so there may be something suspicious going on. And of course, the coding speech also means, and that's why the manually defined search terms never work. Like if you want to steal something, you will probably never write down, okay, let's steal something. You would rather use the coding speech, right? These are the examples from the real cases. You probably recognize some of them. So what helps is actually to use semantic analysis to identify the outliers, the anomalies in the vocabulary. So what you do, semantic analysis is basically clustering to some extent, or we are trying to build up some structures to get some concepts from the larger amount of data. So you vectorize the text, you do the all TF-IDF magic, measure similarities, do or improve the feature selection, feature extraction, and then what I do very often is I actually use the cluster descriptors as the seed words within Leighton-Dirichlet analysis, or within Corex, I use them as the anchor words. This is how it looks like. I can really show you the real life data, or some of them, so you can only see that these are, or you can see the clusters that have the same vocabulary more or less, and then there are some red dots that probably are kind of anomalies in this data set. So generally, I would say that semantic analysis helps us to find hidden patterns in the text, detect suspicious context. We can also use the advanced methods of semantic analysis for the word sense disambiguation, and generally, when you do it automatically, you speed up the reviews significantly. So, of course, the point of Deloitte or any corporation is to save clients time and money. That's how we do that. With an electronic discovery, we now use all these NLP tools to do the better preprocessing, advanced clustering. I need to be quick. So predictive coding, that basically means that you've got the data set from already closed case, and you use it as a training data for the current case, which usually doesn't work. It has the same, or all the issues of transfer learning when you train on one domain or one language, and then you perform or you use the classifier for other domain. It doesn't always work that well. So we rather use Bayesian approaches, but it's more at the phase of experimenting than actually, I've never really seen it in practice so far. This is just to show you how a simple thing like lemmatization can actually help to shrink the universe. This is just to see on 1 million words how the data shrinks, for instance, in Czech and in English. So if you just perform lemmatization on Czech, you can work with 1/3 of the data. And this is on the real project data, where after we got rid of the noise in English, we still got 2/3 of the data. So it was much easier to do the clustering and to work with it. But why am I saying this? Here you can see that if you don't use the lemmatization, you very often get a very bad cluster descriptors. So you get the same form of two different forms of one word, and it leads to nowhere. So I lemmatized the data and I performed the analysis once again, and the cluster looked totally different, and that's how we got to know that there was something suspicious in one part of the cluster, and that's how we found the smoking gun at the end of the day. As for the tools for the preprocessing, well, we very often use some basic Python libraries, but if it's a complex language and we don't have the preprocessing at our disposal, or we don't trust it, which is the case, we use Genia, but there are some other analytical tools specifically for the forensic investigations, and that's relativity and brain space. And I hope I still have some time to show you brain space. Do I? But there are like 3 secure servers I need to log in. And I actually, I hope to be still there, so it's good. Can't be really demoing stuff around because people are actually working on the real cases, so I'm sorry for that. Anyway, this is the Twitter data set from, it's the same principle as we do the background checks on the suspicious people, but I can only show you this data set, and it's the data set I was working on for the Doctors Without Borders, when we were automatically detecting the outbreaks of Ebola and some other diseases at around the area of Lake Chad, because there are no roads and there are like missing maps, and they needed to know in which direction the diseases would spread. So I used this data set to just show you how we also work with that Twitter or social network data when we perform the background checks. So here you can see the red columns that are actually weekends, because it's also a very good hint for us very often that if there is a certain amount of communication during the weekends, it's suspicious already. And here in this matrix, you can see the anomaly detection, or generally the document volume, but also you can see if there is some specific vocabulary mentioned in some specific days. So it's more about the frequency. The more frequent, the more suspicious. Very often. Yeah. That's just the numbers of the documents, meaning the tweets, because we actually prepared the data. Like I performed all the clustering and everything, so these are just the relevant documents, the documents that are mentioning something relevant. So I've done the analysis using Genia and then relativity, and here is just the documents that should be relevant. That mention Ebola, cholera, and some other diseases. Actually, we can see that here. These are top terms. So it's Nigeria, malaria, Ebola, outbreak, and people. That's what we were looking for, because we wanted to know in which direction the diseases are spreading. The documents are the tweets. You can see it also here. I'll get to it, but here you can, for instance, search through I think there is a primary language. So here we check in which language the tweets or the documents are written, or what are the I don't know, people mentioned. Okay, people or gods mentioned in the data, and it's not the case at the moment because it's the Twitter data, but we also very often put together the text analysis and the metadata. So not only it matters what people write, but also to whom and how often. So here you would normally see also which emails and from which domain were being sent. And here, when you find something relevant, malaria, children, you can then also dive into the particular email or tweet or whatever to see whether the vocabulary is actually relevant. And here I would just show you how the cluster wheel looks like after the analysis. Or you can drill down and see what are the most common terms in this part of the cluster. Yeah. And that's how we usually afterwards manually. It's not actually that I would automatically define some evidence and say, okay, this guy should be sent to prison. Of course, I get these 10 millions of emails, but I define like 200 and send them to the lawyers, and then they need to go through them manually to see whether it can actually be considered an evidence. But it's luckily very often the case. So yeah. And then normally the communications would be the metadata, but here you can't see anything because it's not the emails, but it's just the tweets. So there was at least a brief demo of one of these tools we typically work with, and I'm afraid I ran out of time, so I still hope there is time for questions. Thanks.
So thank you very much for the talk. While we set up the screening of the slide questions, we can ask some questions in the audience. I will. Do you have some question? Okay.
So you've mentioned that you need to travel to Europe in order to collect the data because they cannot leave the country. And my question is, couldn't this be solved by some other solution, for example, via using a VPN or something like that?
Well, trust me, we would do that if it would be possible. But it really differs country from country, but there are some specific regulatory restrictions that you can only travel with the mobile server and analyze the data right there in the company on site.
Mm-hmm. And is there a possibility to maybe collect the data and then send them over the internet back here, for example, to the Czech Republic after using an air gap? So download them on the mobile server and then maybe save them offline and then re-upload them to the Czech server.
I get you, and I'm not sure what I can actually disclose here, but there are special agents that still need to travel with the data.
Mm-hmm.
Like we've got people paid for traveling with the servers or the hard disks.
Quite inefficient, but okay. My second question is...
It is, but it's the result of some leaks we experienced, and you don't want to, you don't want to experience that again.
I understand. So my second question is, some of the code open sourced? Can I find it online and maybe experiment with it?
Just for the pre-processing, we used, sometimes we use the general Python libraries like NLTK and stuff, but for the topic modeling, for instance, well, generally I use, for instance, Corex, you can find it on GitHub. Mm-hmm. So some of it, yes, and it then really depends on to what extent I need to adjust it, and also what type of data it is.
Okay.
What are the seed words or the anchor words? But in principle, for instance, I've mentioned the LDA with seed words and Corex with anchor words. They generate more or less the same results. You can play around with embeddings, but it's also open source.
Mm-hmm. So your particular ensemble with the settings isn't open sourced, I guess, but the libraries, Corex and stuff, these are open sourced. Okay.
Like the magic behind this, actually the workflow or the pipeline we put together, and
So maybe in the future we might open source it, right?
Well, we don't really do it because of the potential suspects. That's the thing. Like I would love to leave it open, but generally we employ many hackers to actually that are trying to hack what we do anyways, and if you disclose it, the likelihood that someone will try to get around these things is of course higher. So that's why.
Security by obscurity.
Yep.
Thanks.
Okay, so let's go to the question. So the first question, if I use Google Translator as a middleman, are you still able to perform forensic investigations successfully? Let's say if suspects use Google Translator.
Yes, yeah.
So is there...
Like also, by the way, I sometimes do it within the early case assessment because I don't speak all the languages. So even if I identify something as Arabic, it still doesn't mean that I would understand the content anyways. So within the early case assessment, it's very often the case that I get all the data translated into English. Because, well, it also depends on the language pair. Now, when we basically don't have any interlingua, we always use English as the interlingua, as the transfer language, as we call it. You never translate things from Czech to Chinese. You always translate in between Czech English and English Chinese. And the performance of Czech English or English Chinese translation is pretty good. So it's it wouldn't be an obstacle.
And for the fingerprints and all the like semantic style and syntactic style of the person, can he mask in some way by using these translation services or automatic translations?
Well, I still don't think so. Sometimes, if people are aware of the possibility of the investigations, they are playing around with grammar. Like they pretend that it's a guy if it's a girl. using some other grammatic features. But the point here is very often that people never know that they will be investigated. They're pretty sure that it's never going to happen. And even so, like if we investigate, if we have our suspects, we still investigate the whole company. So if we collect the notebooks, we usually don't go after this particular guy because they would start destroying the evidence immediately. So we always pretend that there is something going on in the entire company. We collect all the data, and then we, of course, focus on particular people.
Okay, next question. How many sentences, words, or text do you need to make fingerprint? Is it based on some special word embedding or something completely different?
Well, you can only use the referential data of 600 words, and that's it.
So that's the minimum that you need to get like accurate result?
Yeah, as a referential data.
600 words, okay.
So it's not worth performing any embeddings. And, yeah.
How do you cope with locked phones, encrypted hard drives, password protected accounts, and when are you etc. When are you gathering the data for investigation?
We do cope with them.
It's actually is it actually your job, or do you get just the unencrypted data?
No, we got a forensic lab where there are people assigned just for that task.
Okay, and can you comment on some ways that they do it, or is it?
Not really. The only thing is that, by the way, it's very often the case in the companies that anytime I log in, for instance, into my company computer, I need to say that I'm okay with any type of investigation anyway. So you admit that it can happen and it's legal. That's why we employ the lawyers.
So the next question is actually the same as the previous one. So, a textual fingerprint, is there a similarity metric defined over the fingerprint domain?
What do you mean by the fingerprint domain? Like, for instance, just the syntax, or just like if there is a baseline?
I guess we can specify.
I think that when you have a lot of people, a lot of text, you create a lot of fingerprints, and then you are trying to find, for example, a guy who wrote something, and is similar to somebody to the other texts.
Yeah, there's a baseline that's been set up based on the general data measured on the average population, or actually the data from the Czech National Corpus, and then we see how much it differs.
Mm-hmm. Okay, thank you.
Yeah, it's like for this is domain independent, so you can just things like average length of sentence and some other features can be just for the purposes of the baseline generalized based on corpus data.
Language using people on Facebook, so it's pretty different language.
Yeah, but for these purposes, it does. I mean, it's enough. And also, you've got different types of data sets in the Czech National Corpus today, so it's not just the old 90s printed newspapers. You also have spoken data. And, yeah.
So what I understood is that you calculate all these like features as a average number of syllables per word and stuff like that, and this is the vector, and you then do the cosine similarity based on the actual text that you want to like investigate, and to some special text that you know some other person writes, and then you compare the vectors, right?
Yeah,
and find like the most similar one by the cosine similarity.
Or Euclidean distance. Yeah.
Okay. So, would you be able to use internet browsing history of suspects? Some companies collect such profiles, for example, for ad targeting. Do you cooperate with them?
Browsing history, well, we cooperate with companies like Apify to collect the data, but No, we don't use any. We don't cooperate with Seznam or Google or any of these.
This is
we
probably
collect like a fingerprint or the profiles, but well, usually it's enough anyways, since people.
This is
I'm not
probably
saying that people are stupid, but very often they really leave traces all around the internet, so it's usually enough.
Yeah. So this was meant more like you collect the computers from the people and then check their history. So it's not needed even.
No.
Okay. So since you are working with probabilities, how often do authorities use your results just as leads, and how often as evidence as court? Does it even can it even be used as evidence?
Yeah, well, usually it's together with some other evidence. Like I've never, well, actually the case with the sexual harassment, for instance, the guy got kicked off from the company after 3 months or something, but and he had to pay some money. And the email served as the only evidence. That's true. And yeah, maybe there were some witnesses, the ladies, that actually the whole case was based on the whistleblower report. But it's actually stated in the law, and it started in the US, that it can still be used as an evidence nowadays.
But it's the email. It's not the result of your predictions and machine learning models, right?
No, as I said, I can't say, okay, this guy needs to be sent to prison because my machine learning model says so. And you don't want it, by the way. So, yeah, the lawyers, they then, when I say, okay, this is a suspicious email, they still need to read through it and say, yes, it actually fulfills the...
So there is no, like, in the courtroom that somebody say, prediction is 95%, so you're guilty. No, nothing like that. Okay.
No, but that's true. The first case I've mentioned with the suicidal letters, that they take it pretty seriously because it was surprisingly big enough, the training data set, that we could say, okay, these are the very characteristic features.
Okay. So what does lemmatization of words mean? I mean, it's something you could read probably on the internet, so let's not waste the time and stay on the topic.
I'm so sorry. For me, it's always difficult to make sure that everybody is on the same page and nobody gets bored and the others still know the basics. And since you had Genia last time, I suppose that, you know, lemmatization. Sorry for that.
Yeah, because of the time pressure, we need to keep the questions directed on the speaker and not like on the general side of the things. And the next question is the same, yeah, so...
Oh yeah, maybe. That's a perfect training data for trolling detection. Thanks for that.
So tasks such as hate speech detection or error event detection always have an issue of lack of positive samples. Could you share some experience dealing with these imbalanced datasets?
Well, again, the point here is not... it's not a recall, it's a precision, so we don't really care what we missed, and again, it's not the direct evidence. So if I say that something is probably hate speech because of the sentiment analysis classifier I used, then it's enough, and I don't really care about positive. It's the same. Like it's usually behind there's a general sentiment analysis model which can be trained on whatever, but in this case we can still use it because the hate speech vocabulary is quite condensed, to be honest.
Okay, and the last question that will be answered on the stage: how accurate is the suspect identification based on writing style, and how big is false positives and negatives ratio?
What was that again?
The second one, yeah. The first one is probably another training data for trolling. So.
Yeah, I do the general-based analysis. It's pretty interesting to me as well. Again. I'm just thinking about the numbers because it really differs and it depends. But we manage something about 80% of accuracy. Yeah. But again, everything needs to be confirmed by the lawyers. Anyways.
Yeah, so it's like research. So, other questions, trolling or not, are you can ask during the networking. Katka will be here, so all the questions can be answered if you find her somewhere on networking. And I will give the word to Pavel.
Thanks again.
Okay, thanks to the speaker.